Alright, in this problem we're asked to consider the position function negative 16t squared plus 128t representing the position of an object moving vertically along a line. Sketch the graph of S with the secant line passing through 0.25 and then S of 0.25, 2, and then S of 2. Determine the slope of the secant line and explain its relationship to the moving object. Okay, so the first thing that we want to do is graph this. So if you have a TI-83, TI-84, I went ahead and typed this in ahead of time. So go to your y equals button and graph this. Now, if we hit graph, there's what's going to happen. We can't really see much. This is 10 by 10, 10 by 10. So we need to change our window. Let's go to the window, and we can look up here and we can see that the x values that we're looking at are 0.25 and 2. So we really only need the x to go from 0 to, say, maybe 3 or 4. And we'll go to 4 just so we can see kind of what the graph's doing, but cover these 2 points, 0.25 and 2. Okay, as far as the y goes, that's kind of going to be something you have to look at the function and kind of get an idea. Like if we plug in a 1 here, this would be negative 16 on that. That would be 128. Okay, so we're looking at a pretty large number, 112 right off the bat. If we plug in a 2, that's 256. This is going to be negative, I think, 64, but it's still very big. So it's going to get into the hundreds pretty quick. So let's go up to like 300 and see what that does for us on the y max there. Hit a graph here. Okay, it looks like we got a pretty good representation of the graph. So here, right there. Okay, and this is about 300 up here. That was what our window was. So this gets up there just less than 300, maybe like 280 or something. Okay, so now that we've got it graphed, we want to find the secant line. So how we're going to do that, it's going to be S of B minus S of A over B minus A. That's the secant line. So you're going to have a point here, and you're going to have a point here, and you're going to try to find the slope of this secant line. Okay, so what is that secant line? Well, we can use our calculator to figure that out. We don't have to. We could just plug in these points, 0.25, into the function in place of t. So S of 0.25, and that would equal negative 16, 0.25 squared. And remember, that is 1/4. It might be easier to do it that way. This is just how the problem was written, plus 128 times 0.25. Okay, and then the other one would be S of 2 equals negative 16, 2 squared plus 128 times 2. Okay, since we've already got the thing graphed in our calculator, we can use the calculator to get these values pretty quickly. You can do that by hand too if you want, but let's go ahead and do it in our calculator. So how I'm going to do that, I'm going to hit second window, and it's going to bring me to this screen. I'm going to ask on the independent variable, and then I'll hit second graph, which will bring up a table. It's empty right now, and I'll just plug in the value. 0.25 gives me a value of 31, and then 2 gives me a value of 192. Okay, so this first one was, I'm kind of running into my graph here a little bit, but this is equal to 31, and this is equal to 192. Okay, so the secant line is going to be 192 minus 31 over 2 minus 0.25. Okay, we can use our calculator for that as well. 192 minus 31 divided by 2 minus 0.25, and we get 92. All right, 92 is the slope of the secant line. Okay, and this would be the average velocity between these 2 points. So the average velocity as it's moving along this line between 0.25 and 2 is 92.